Come see the moon. Come see the moon. Here, come see the moon. We got it at high power. Looking at the moon. Come see the moon. Come see the moon. Come see the moon. Yeah, come see the moon.
Thank you. That's awesome.
That's the way the moon would look 1 hour before you landed on it. We're looking at the moon.
Yeah, thank you. That is really cool.
Holy moly. Wow, what a 3D thing.
That's amazing.
As I always say, the exterior decorator does lovely work.
I've never seen that before. That is absolutely incredible.
Can you explain how this works?
Works fine. The light comes down through here and hits a mirror.
I know there's a mirror in here some, but I don't understand.
Well, look at the front end. Look down the front end. There's a concave mirror there. The light hits that and then hits this little mirror here and comes out into here.
Oh my God! That is incredible! You can see pock marks and everything.
The moon's all craters. There's nothing on the moon that's not a crater.
That's fabulous!
What makes a Dobsonian telescope?
It's a retarded. It doesn't track things across the sky for photography.
Because it's not equatorial. On
No.
the equatorial planes, you mean?
No, it doesn't do that.
Yeah. So you can't put a clock drive on it, huh?
Well, we could, but we don't do it. This runs on yogurt and eggs. I eat the yogurt and eggs.
So how big across are those craters that we're looking at generally, like the bigger ones?
All right, I'll show you one that I can give you.
Okay.
The one you're looking at is as big as Texas.
Yeah, it's the view.
All right, now you'll see 3 dark smooth areas in a row. 3 dark smooth areas in a row.
3 dark split. Yes, I see that.
The middle one is the Sea of Tranquility. That's as big as Oregon.
Oh, wow.
If you had a picture of Oregon that big, could you see Portland? Never mind the footprints.
I would think yes.
No, you couldn't.
You could see Portland?
Oh my God, it's so magical.
As I always say, the exterior decorator does lovely work.
Oh, I needed this right now.
We're looking at the moon. Come see the moon.
Oh, that's incredible.
Can I look again?
Of course you can look again.
Yeah.
This isn't like ice cream. You can have as many servings as you want.
When is it waxing or waning?
When the bright part is getting fatter, it's waxing.
Waxing, okay.
When the bright
waning.
part is getting thinner, it's waning.
Okay, waxing.
So it waxes from new to full.
Okay.
It wanes from full to new.
Truly amazing.
Now, the reason you can see the mountains so well is because the sun is shining on one side and not shining on the other side. Look again, you'll see. The mountains are lit on one side and shady on one side. That's why you can see them. When the moon is full, you can't see the mountains. They're lit on all sides.
Oh my, that's wonderful. Never saw this before. Gee.
Well, now you belong to a minority.
Oh my. Isn't that beautiful?
See the moon. Come see the moon.
Look at the craters.
Oh, it's gorgeous.
What language do you know besides English?
Henry?
北京的话，没有手。
What are we looking at?
Each other. We're looking at the moon at high power.
It's all one big crater.
No, it's not all one big crater. It's millions of craters. But this one with this big mountains around like that, that crater is big enough to put Texas in the hole.
Wow, that is so cool.
Only the shady side is cool.
Look at that. Oh my God.
How can they look at it? You're looking at it.
Oh, that's so exciting.
The light that's hitting this telescope is how many seconds away?
1 1/3 seconds, the light comes from the moon. Something like that.
250,000 miles away.
Actually, the separation is 0, you know.
Oh, John, don't do that. That gets so complicated.
No, it's not complicated. More complicated the way you think it is. Because you think something's moving around like that. And nobody ever saw anything doing that. There aren't any photons. But at any rate, the way we usually see it is that the moon's 250,000 miles out there, and it takes the light 1 1/3 seconds to get here. That's the way we usually see it. That's the way we usually talk about it. But you know what somebody told me the other day? The universe is mostly hydrogen and ignorance.
Hydrogen and ignorance.
Come see the moon.
Oh my goodness.
Now you see that ridge of mountains?
Yeah.
That long ridge of mountains? That's the edge of a crater. The crater is big enough to put Texas in the hole.
Oh my goodness. How high are the mountains?
Those mountains are as high as the Alps.
Really?
Yeah. But when they see the moon, they are shocked. The public is so shocked when they see the mountains on the moon. One of the reasons we do this is so that people can see beyond their genetic programming. Your genetic programming says, oh, these are clouds, oh, that's blue sky between the clouds, and these are trees, and these are plants, and these are flowers, and these are bees, and these are people, and these are dogs, and these are cats. All those things are covered by your genetic programming. But when you look through the telescope and see the mountains on the moon, damn it all, your gonads shut up. They have nothing to say about it. And they have nothing to say about Saturn's rings. And they have nothing to say about galaxies or any of that stuff you see. So you see, when you let people look through a telescope, they at least have a way of seeing something from a standpoint which they have not had before. How many of you did not get orange flyers? All right, then you're going to have to spread them around. This smooth area is a big crater where the asteroid went all the way through the crust down to the mantle. And if the asteroid takes the rocks on the top off, then the lava melts and it comes up and floods it. Okay, go ahead. This is a smaller crater. This is called Copernicus. And you have to think what happens when you have an asteroid coming in so hard that it leaves a hole big enough to put Los Angeles in the hole. What you have is a tremendous explosion of vaporized stone steam, okay? And it condenses to spherical glass beads. So that's what all this white stuff is. These are glass bead streamers. Go ahead, let's have another picture of the moon. See when the moon is full, you see all these glass bead streamers from the crater Tycho? They're 1,000 miles long. They reach from San Francisco to Denver, or from New York to Chicago. The tidal effect of the Earth on the moon has stopped the spin of the moon with respect to the Earth. The moon keeps the same side facing us all the time. Doesn't matter when you look at the moon, you see the same side. These high school girls came and looked at the full moon. And since the moon was full, I told them that when the moon is full, you don't see the mountains nicely, but you see the glass bead detail. I said 1/3 of the surface on the moon, 1/3 of the surface on the moon is glass. I said it's all over glass bead. And this girl says, how do you know that? I said, when the astronauts went there, they brought that stuff back. Someone went there. Someone
They didn't know
went
that?
there. She asked me twice.
Oh, this is really profound. I'll tell you, this is absolutely mind-boggling up here. Gentlemen, I can well imagine that a foreign planet must be a weird thing to see. Okay, Caliban and Snoop, 3 minutes going over the hill. Let her on down. Okay, 6%, plenty fat. Contact. Stop. My golly, this time goes fast. Oh, look at the mountains today, Jim, when they're all sunlit. Isn't that beautiful? It really is. My golly, that's just super. Unreal.
What you do see on the moon is when they scuff in the dirt, it just goes up and down. There is no dust cloud. The dust goes the same way the boulders go, over and down. The dust goes the same way the boulders go, and you can't do that here. And when that machine is running, the stuff goes up from behind the wheel, up like this. Because there's no air to keep the dust up there.
Boy, Houston, the beauty of this place is absolutely incredible. What a ride, what a ride. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light."
Adam is talking to God just after God has made Eve. And Adam is kind of complaining to God, how come you made her so sweet and so attractive? And God said, so you'll like her. Well, how come you made her so stupid? So she'll like you. I have to tell you another story. I have to tell you another story. This is a story about the future, when the scientists have learned to make life. So they approached God and suggested he might consider an early retirement. After all, it was always your job to make life. Now that we've gotten that done, you might consider early retirement. So God wanted to see how they do it. So they take him down to the lab, and the scientist says, first you take some dirt. He said, get your own dirt. These are the main talks. I know we're in Vermont, but they're the main talks.
We all know what a Dobson telescope is.
You watch it.
But I'm not really sure how many of us are quite aware of the incredible contribution that John Dobson has made. That he stands really right next to Newton in his role in creating a telescope that he says is used for the rest of us. John, it is such an honor to have you here each year at Stellafane.
Well, years ago, I was in Boston to do a program, and there was a lady from South America there in charge of feeding me and sleeping me. Mm-hmm. And in her inimitable accent, she said, I don't know much about astronomy, but I read in the magazines there are these different kinds of telescopes. Uh-huh. There are Newtonian telescopes, and there are Dobsonian telescopes. I thought Dobson died a long time ago. The first time I taught a telescope making class was in San Francisco, and somebody called out, who is John Dobson? I said, I am. And he says, who are you? Are you an astronomer? I said, no, I never took an astronomy course in my life. But when it comes to making telescopes out of junk, I'll stand my own ground. When I first made one of these telescopes, my friend told me you can grind your own glass. I thought he was nuts, you see. But when he showed me that you could really grind your own glass, we made a 12-incher, you see. And when I first saw the third quarter moon through that, I thought, oh my God, everybody's got to see this. That's really what happened to me. As soon as I saw what you can see through a telescope, I thought everybody's got to see this, because what we ordinarily see is nothing like what the universe really is about.
What prompted you then to take some of the telescopes that you build or helped others build and then take them out to the national parks?
Through smaller telescopes within the cities, you can see the planets and the moon. And with the sun telescope, you can see the sun, because those things are not intimidated by these lights. None of them are, especially the sun. But if you want to see the rest of the galaxies and things, the rest of the universe, you need a big telescope like this, and you need to get way, as I always say, high above sea level and a long ways from LA. You've got to get out of the cities. So if you want to know where out away from the cities the American public goes, it's in the national parks. The national parks have fabulous seeing conditions, and they have all the people already there. You know, for a long time there was this term backyard astronomy. Mm-hmm. We're not backyard astronomers, we're sidewalk astronomers. We do it in the front, so that
front yard. Okay.
Everybody can see. We go to places like Ghirardelli Square, Hollywood and Vine. We go to places where the people are.
What's so special about these telescopes that they become known as Dobsonians?
They go up and down like a cannon, and they go round and round like a cannon. This is the simplest solution to aiming anywhere above the horizon and having it stay there when you let it go.
He started the whole large telescope field for us amateurs, because without the Dobsonian mount, you couldn't build a reasonable scope over 8 or 10 inches. You know, that's how we were able to build 25, 30 inch, 36 inch Dobsonian scopes.
This is the old way they did telescopes, like for this one right here. Heavy duty equatorial mount. If you had anything 8 inches, that was big. Now you have a low, cheap, flexible, lightweight mounting system. The other thing he also made is he made them affordable, these things. So he was able to open up a scale of astronomy that hadn't been there before. You're going to think a lot more people are getting involved, or they're able to get involved with cheaper, larger telescopes and experience it better. The larger the optics, the better, more light they gather. The more light they gather, the better you can see things. It started a revolution. Now people were getting 14, 16, 17, 20, 25-inch telescopes, something I never would have dreamed of. I thought I'd have to build an observatory. I thought I'd have to spend thousands and thousands of dollars. I mean, I saw him yesterday in the tent. He said he built a telescope for $7. I mean, it's one thing to look at pictures, but to look at it in your eye, it's really different than pictures. Pictures don't do it. Never did it for me. When I actually found my first deep sky object in the middle of the winter with my little 2-inch desktop refractor, I was hooked. I was never the same again.
His design was a priceless gift to really, to not just to astronomers, but to people. How you can't put a price on that. He could have patented that design and made a lot of money, but he pretty much just gave that idea away so that other people could copy it and proliferate amateur astronomy to a whole new level.
It's the simplest way to aim above the horizon, and I don't know why the hell they blame me for it. We just wanted to see what was going on out there, and the easiest way to aim is above this way and around this way. And it's like reinventing the cup or reinventing the spoon. We've had them all along. They were going to give me an award for public service in the Astronomical Society in Oakland, you see. That's East Bay from San Francisco. And if they're going to do that, somebody's going to sweet talk you in front of the crowd. So they're sweet talking the Dobsonian revolution, the Dobsonian revolution. I got up and said all the previous revolutions were run with the cannons on Dobsonian mounts. When I was in high school, I was an atheist. I could see that these two notions cannot arise in the same being. Do unto others as you would that they do unto you. And if you're not a good boy, it's into hell for keeps. There is no way that these two ideas can coexist. And so I became an atheist, a belligerent atheist. I would take on anybody. So what happened was, quite a lot of years later, a musician friend of mine, Lou Harrison, took me to hear a lecture on a Sunday morning. Now here I am, a belligerent atheist, going to hear a lecture on a Sunday morning. And as soon as that man opened his mouth, I knew I'd made a mistake. I could see that either there's something underneath this world which I haven't noticed, or this guy's not here. It's a little bit, I think, like what Einstein said. When they gave him, when he was a little kid, somebody gave him a magnet. And he said later on about it, he said, something deeply hidden had to be behind things. This one knows about that one, and that one knows about this one. Something deeply hidden had to be behind things. So that's what I must have seen, you see. Now, once you become persuaded that there is something underneath, if you become persuaded that there's something to do about it, then you want to find out the people who are trying to do something about it, and they happen to be monastics. By 1940, I was seriously interested in doing something about it, but the Swami sent me back to the university. I had to finish at the university. Organized monasticism is Buddha's personal invention. There were no organized monasteries before that. So we're called the Vedantins. Veda means knowledge, and Anta means culmination thereof. So Vedanta just means culmination of knowledge, that's all it means. And so they're primarily interested in information, not just spooky stuff. The man who founded the order, Swami Vivekananda, he wanted sadhus, holy men, to go from village to village with magic lanterns to educate the villagers in science. He wanted it done. You grab hold of the top here, put your foot on the tube before tip it over, and you're off like a rickshaw.
Yeah.
You're off like a rickshaw. So I used to wheel him around the neighborhood like that. So some kid would see it. He'd ask, "What's that?" I said, "It's a telescope. Do you want to borrow it?" Of course he wants to borrow it. But then some of those people wanted to make their own telescopes. Then I was in real trouble. Then I had to decide. Either I tell these people to go to hell, or I help them make telescopes and probably get thrown out of the monastery. And I didn't tell them to go to hell. Anyway, I want to hear all the troubles that you had. Come on.
How far to the perimeter should I be going?
You've got to get your curve all the way out to the edge.
All right.
Come over and see this. Get over here and see this.
I figured out how to wet it down and spot it to figure out the distance, and it's at 5.7 right now.
You see, this was his original curve. This is the curve that he's been grinding, but he hasn't gotten it all the way through, you see. Got to take this curve farther down through. What you have to do is to go over here. And then turn it, because the mirror's on the bottom. Who's deeper?
He's deeper than me.
He's deeper than you?
This is pre-ground. This is mine. This is his. So I think mine's too shallow. This is perfect, and yours is too deep.
Yeah.
That's what it looks like.
I think I just make maybe just use this.
It's hard to tell.
Everybody knew I was running around helping people make telescopes. They already knew that, you see. But in the monastery, you're expected not to be AWOL, absent without leave. In the monastery, it is assumed that you were AWOL. You did it. You did it. So that's the problem there, you see. And so somebody was asked to watch for me, and he couldn't find me when I was out in front of the big brick wall, weeding between there and the sidewalk with Mrs. Fitz and her 2 kids. I've got 3 witnesses, but I was reported missing, and I was asked to leave. So that was in 67. By 1968, we started the Sidewalk Astronomers.
I love that Sidewalk Astronomy that you bring that. When I first time moved the 25-inch to Tsim Sha Tsui. Tsim Sha Tsui is a place that is the most busy place in Hong Kong, and wow, there is a long queue. 300 people. So, you know, so touching, the feeling. They look through the scope and see the Jupiter and see the moon
and Saturn's ring.
Wow, they just, wow.
Of course.
Everyone has the same response.
Now you see, if there were 1 million people with telescopes willing to get them out for the public, there would be a chance for the people born on this world to see where the hell they are.
When you build your first Dobsonian, or when you complete your first idea of the Dobsonian and make it practical, what is your instant?
I didn't have any idea. I was just trying to aim above the horizon.
Ah, yeah, exactly.
I wasn't trying to start anything. They shouldn't have called them Dobsonian. But that's the simplest way to aim above the horizon. Up and down this way and round around this way. What the hell else is there? But you know what happened was, back in the 60s, the telescopes were 4 inches and 6 inches, and they were too small to show galaxies. So the only way they could do is set up on machinery so they track things for photography. There, you can see the picture with your eyes in the daytime, but you can't see the galaxy through the telescope with your eyes.
So then, sometimes
if you let them see through a 10-incher, they go bananas. They go nuts. They cannot believe that the moon looks as though you could walk on it. And they can't believe that Jupiter has moons like that. Well, they might believe a little bit about those things, but they certainly can't believe that the exterior decorator hung something like Saturn out there. No, that's not acceptable. This is Saturn from the ground. Let's have the next one. It's not from the ground. Now you see the space in the ring here? There's room in that space to drop the moon through it. Got the picture? This is wide. This is 2,000 miles across this crack here. And there's room to drop the Earth and Venus together through here. This is about 16,000 miles across here. And this is almost big enough to put 1,000 Earths inside. This is an orbiting snowstorm, this ring, and it's not as old as Saturn. That one of Saturn's moons, made out of water ice, mostly water ice, got too close to Saturn, and the tidal effects of Saturn smashed it to an orbiting snowstorm. So this is Jupiter with a great red spot. Now, if you had a blanket big enough to show the next one, please. If you had a blanket big enough to cover the great red spot, you could wrap the whole Earth up in your blanket. Jupiter is big enough to put 1,300 Earths inside, and it spins around faster in less than 10 hours. A day on Jupiter is less than 10 hours. Don't go to Venus. It rains sulfuric acid, and the ground is hot enough to melt solder. The atmospheric pressure on Venus is as much as being 2/3 of a mile under the ocean. So don't go to Venus. Mars used to have enough atmosphere to hold water there, but it doesn't have it anymore. Mars is a little smaller than we are, and it doesn't have as much magnetic field, and it doesn't have enough Van Allen belts to keep the solar wind from blowing the atmosphere away. This is a dried lake on Mars, and we're quite sure that it used to be a water lake because we don't think there are any other liquids in large enough amounts to leave these shorelines you see as the lake dried up. This is the Grand Canyon of Mars, and it would fit all the way across Australia or all the way across the United States. And the Grand Canyon of the Colorado would fit in this little gully. This is the big volcano on Mars. And it's big enough to cover the whole state of Oregon. The lava pit on the top, you see, is bigger than San Francisco Bay with all the surrounding towns thrown in, you see. And this is nearly 3 times as tall as our tallest mountain. This is our sun. Our sun is a teeny bopper, and it has magneto-hydrodynamic zits. If the sun were the size of a basketball, Jupiter would be the size of a grape, and the Earth would be the size of a very small grape seed. There's room inside the sun for the moon to orbit the Earth inside the sun, with 250,000 miles left to spare outside the moon's orbit. The sun is hotter when it's spotty, and you know about the Maunder minimum. In the Maunder minimum, they didn't see any sunspots for a long time, 66 years or something, and Europe went into the mini ice age, and that's when the fireplace was invented. Before that, they all slept in a central room with a fire, and after that, they had fireplaces in their rooms. Anyway, it's interesting that we're connected to the sun that way.
Sunspots, of course, are caused by magnetic eruptions. You can describe them as magnetic eruptions, magnetic fields leaping out of the sun and falling back in. And sunspots are about 2,000 degrees cooler than the rest of the sun.
The way I usually put it is the sun spins, you see, but the equator goes around too fast. The equatorial regions go around in about 25 days, the polar region in about 35 days, and that tangles the magnetic field all up. After 11 years, it gets so tangled up, it starts buckling through the surface like sea snakes, and we have a rash of spots. Because it's a loop, it's a magnetic loop that comes out, you see. And that's why some of the pictures of prominences you see from along the edge, these big loopy things, that's why they're loopy.
The amazing thing about the sun is it loses 4 million tons of mass a second. It's been doing that for 4.5 billion years, and it will continue doing that for another 4.5 billion years.
Let's do the history of the sun a little bit. It fell together by gravity till it got hot enough inside for the hydrogen to fuse to helium. If it fuses too fast in the middle, what will happen? It'll bloat and cool off. And if it fuses too slowly, it'll collapse and speed up. Now, isn't that lovely? That's the only reason we're talking English. Is that clear to you all? If the sun didn't have a governor on it, so it stayed at the same temperature, English would never have arisen on this stupid planet. But after the helium accumulates in the middle and has no longer hydrogen mixed with it to keep it bloated like that, then the helium will collapse. And when the helium collapses, it will get so hot that it will explode to carbon and oxygen. That's as far as the sun will go. So first the sun swells up to about the size of the Earth's orbit, but it'll be puffing stuff away on the outside, so it won't hang on to it so tightly. So at that time, the Earth will drift away to about where Mars is now. The Earth at that time will be melted. The air will be long gone, the oceans will be long gone, and the rocks will be molten. Cheer up, things are sure to get worse. Murphy was just guessing. There are only 3 ingredients in this universe. There's hydrogen, helium, and the dust of exploded stars. And this is the kind of stuff out of which the Earth is made, and this is the kind of stuff out of which our bodies are made. And if you give this cloud another 10 billion years, it will go to school and chew gum. So the Earth is made out of the dust of exploded stars. Our bodies are made out of the dust of exploded stars. Not the water in your not the hydrogen in your water. That's original. Have a look at the sunspots. Sunspots. The big green thing is the sun. Those dark spots are bigger than the Earth. The sun's big enough to put 1,300,000 Earths inside.
Oh my God. What is this mirror reflected out of the light off?
This reflects 95% down there, see? 95% down there. Then we lose 96% of the remainder down there. Then we lose 99% of that remainder in the green welder's glass. We let's use about 10 1/millionths.
Whoa, that's intense. Thank you.
Come on, have a look. Now you see one very dark spot right at the end of that patch?
Uh-huh.
That's as big as the Earth, in case you have any delusions of grandeur.
Wow.
Come see the sunspots. Come see the sunspots. See, nobody needs to know anything that they don't already know. Also, they expect us to charge them money. And if we're not going to charge them money, then that's much worse. Then what do they want? But most of the public is not interested in the nature of the real world. That's not part of their problem. Their problem is how to get fed, how to get their laundry done, and stuff like that. How to get their car paid for, and their rent paid for. And they're really not concerned about how the universe runs at all. One time I had a telescope here, this one in fact, and I asked this lady if she'd like to see the spots on the sun. So she came and looked, and then she says, "The sun doesn't have spots. Don't be so negative. Don't be so negative." And she walked down through here and told everybody not to come and look at the sun. So then the lady came out and told me that. And she'd give me another tongue lashing. "Don't be so negative." But you see, she thinks the sun is perfect. And it has to be round and not have any spots. The fact that she sees them is beside the point. Come see the sunspots. We've got the sun in captivity. When you find out that there's information connected with this thing, then, oh my God, look, there's all this other information. But if you don't look at all, you don't notice. Once you've come to the conclusion that what you know already is all you need to know, then you have a degree in disinterest. Come see the sunspots. Come on, come see the sunspots.
Now, what do I do?
Just look through there. Don't put your hand on it. Just look through there.
These are the
These are the spots related to the flares.
Yeah.
These are the spots related to the flares. Come see the sunspots.
Do you see it?
What? Oh,
Sonnenflecken. Sonnenflecken.
you sound like you have an Irish accent.
I have an Irish accent. I'm half Irish. I'm half Irish and half English and at war with myself. Even though some of those people will look, they're not interested in what they see. They don't have nothing inside a response to what they see. So they just look and go. Most people just look and go. But some people are really interested in what they see. They have some background information into which this fits. People have no idea what's going on in this universe. They have no idea at all. And you see, when little kids look through this, I tell them those spots are bigger than the world. They don't know anything about how big the Earth is. Sometimes bigger than Golden Gate Park. They know how big Golden Gate Park is. They have no idea how big the world is. That's a meaningless statement to them. Did you want to see the sunspots? Those people do not reject us for what we are. They reject us for what they suspect that we are. And that's an entirely different thing. Panhandlers on the sidewalk. Why should anybody stop to show them the sun? Don't you see how ridiculous it is? Who would do that? You see, our telescopes are not rejected for what they are. They're rejected for what people suspect that they are. And they have no way to know that I'm not a dirty old man. Did I tell you the story of the dirty old man? Channel 9, the public television channel here, asked me to do a 15-minute telescope making thing for Channel 9, which was going to be showed to the schools. Well, I didn't want to be showing somebody who already knew how to make a telescope, and I didn't want to show a man how to make a telescope. So I asked this girl who lived down the street, 14-year-old girl, if she'd let me show her how to make a telescope on public television. So she agreed to do it. And at the end she told me, "I always saw you there on the corner with the telescopes. I thought you were a dirty old man. Now you're my favorite dirty old man." The astronomers named things before they knew what the hell was going on, you know. And almost anything that didn't look like a star was called a nebula. When I was a kid, it was called the Great Spiral Nebula in Andromeda, which we call now a galaxy. Nobody called them galaxies when I was a kid. It was a Great Spiral Nebula in Andromeda, and nobody thought it was out there. Thought to be in here. The word galaxy is the Greek word for Milky Way, that's all. Galaxy as in lactic acid. Galaxy is a Greek word for Milky Way. So we live in the Milky Way, Milky Way. And the number of stars in our galaxy is equal to the number of grains of wheat, 3 feet deep, over an 8-acre farm. If you had trucks of wheat dumped into an 8-acre farm till the wheat is this deep, and you made each grain of wheat into a star, you could make our galaxy. The Andromeda galaxy is about twice that big. Now, all this dark stuff that you see is the dust of exploded stars. It's still mostly hydrogen and helium, but there's a little bit of dust in it so you can't see through it. Now, if this were our galaxy, our sun would be way out here in the boondocks. We're a long ways from downtown. And in our galaxy, it takes 100,000 years for light to go all the way across. My favorite galaxy? Oh, I suppose our own. But if you mean outside, I'm very fond of NGC 4565. The central bulb's about this shape, and the disk is as flat as a plate, and we see it edge on. If you see it in very dark skies with a good-sized telescope, like a 24-incher, you see, it's quite a large thing in the eyepiece field, you see. And the dust lanes are so conspicuous. You know, the Hubble telescope took a picture of a section of the sky where they couldn't see anything. And there's all these thousands of galaxies in there. It's a piece of sky that's as big as a grain of sand held at arm's length. The universe is a lot bigger than the Earth, and it's a lot bigger than the solar system, and it's a lot bigger than our galaxy, and we owe it to ourselves to notice it. Technically, astronomers are about stars, and cosmologists are about the cosmos. And I'm primarily about the cosmos. I want to know about the whole ball of wax.
What is the age of the universe, and how do we know it?
Who told you there's an age? Wash your mouth. Now you see, right now, there's this modern view running around that the universe had a beginning. Now I'll tell you how it happened, you see. What the astronomers noticed was that all those distant things are redshifted. Okay, they're going away. That is to say, the interpretation of the redshift was that they're going away. And the simplest and most straightforward explanation for that is that long ago there was this big explosion, and it's called the Big Bang. Probably some of you have heard of it. Do any of you not understand redshift? If you don't understand redshift, please put up your hand. Thank you. One hand will do. Redshift is something that happens in radiation, but if you don't know about that, you do know about fire engines. When the fire engine is coming toward you, the bell has a high pitch, and when it goes away, it has a lower pitch. Ding, 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 goes away a lower pitch. Now, the reason that it slurs like that is because the fire engine missed you. Anyway, radiation does something like that. If something is coming toward you, the radiation, the light, has a lot of energy. That corresponds to the high pitch of the bell. But if it's going away, it has a very low energy. That's called redshifted. And the universe does not have a rule that if you see something going away, it had to start where you are. The universe observes no such rule. Anyway, so I don't think it happened like that. I think the universe has been going on like this all along. There are too many problems that the Big Bang has to face. Too many problems. Getting everything out of nothing is of course the worst problem. That's why I tell the story about that king. I think I told you this story. There was this king who came from a very distant place to his capital city, and he didn't get a 21-gun salute. So he called the mayor. How come I came from a very distant place to my capital city and I didn't get a 21-gun salute? Your Majesty, there are 3 reasons. First, there are no guns. He said, never mind the other reason. So I have several objections to the Big Bang. First, you can't get it out of nothing. Never mind my other objections. So the first problem is that even if we could get nothing to make everything out of nothing, we would still have this terrible problem that it would be in a black hole. Second thing we have to do is to overlook the physics of black holes. So we invent 2 particles. You're allowed to invent particles if you don't have any observational evidence against them. Okay? So we invent 2 particles, one that makes matter out of antimatter and one that makes antimatter out of matter. You can do it if you do both of them. You can't do just one at a time, but you can invent 2 of them. And the one that makes matter decays more slowly and leaves the universe as the residue. Now that charms the hell out of me. The Hubble telescope was asked to look and see whether there are any clouds of hydrogen between 3C273 and ourselves. And it says there is. There are between 9 and 12 clouds of hydrogen between 3C273 and ourselves. Now, the Big Bang model says there should not be any clouds of hydrogen in there because there's no way to put any clouds of hydrogen in there. And there's no way to have clouds of hydrogen hanging around in there for 15 billion years, not condensing into something we could see. Now, recently they discovered that the expansion rate is apparently speeding up instead of slowing down. According to the Big Bang model, it has to slow down, and if it's speeding up, they're in big trouble about it. We used to change the model to match the physics. That is not what they're doing now. They're changing the physics to match the model. So they invent this new thing called dark energy in order to speed it up. And then we found out another thing in fairly recent times. About half of the neutron stars that we know about have escape velocity from the galaxy. Oh, Baba. Now, escape velocity from the galaxy is 300 miles a second. Now, that's one thing Star Trek failed to show. A neutron star going, oh, everybody would be jerked away like that. It would have been such fun. The density of a neutron star is 100,000 U.S. aeroplane carriers, all covered with aeroplanes and sailors on parade, squeezed into a 1-pint mayonnaise jar. And they're about 10 or 20 miles in diameter. And about half of them have escape velocity from the galaxy. And they're going out into the hovering layer. And you're not about to see them. They're too bloody small. Anyway, so I think the dark matter is ordinary matter. I don't think we have to do all those fancy things about it.
It is through the process of verbal battles, back and forth, different ideas, that we get somewhere.
Yes, but they don't do that anymore. The difficulties of the Big Bang are no longer discussed at school. I have friends who have been through the university in recent times, and that's the opinion now. The difficulties with the Big Bang are no longer discussed. It's taken now as gospel truth, the same as the people do in the Bible Belt. It's one problem after another with all sorts of magical solutions. You try to persuade some little kid that something came out of nothing. There's no way. You can never persuade a kid. He has to have graduated from high school before he could possibly be stupid enough to think like that. And you look into it, you'll find that all the Big Bang people went through high school. You look. If I've done enough about making fun of the Big Bang, I have to replace it. Because it's not fair to make fun of somebody's model without replacing it with something which you think is a more reasonable model. So I'll have to replace it with what I think is a more reasonable model. So first I have to tell you another story. It's about the same size. We'll say that a Martian lived in Berkeley for 20 minutes on a Thursday afternoon. And he saw the barber pole going up the wall. And he would right away conclude that it started at the sidewalk in the morning and it'll reach the roof by night. He's only there for 20 minutes. But you see, we know that the stripes recycle. So in my model, we have the stuff recycling from the border. Now, you might not think that the universe has a border, but it does, you see. When we look way out there, all the galaxies and things appear to be running away from us, and the farther away we look, the faster away they're running. And if you go out too far, they're running away at the speed of light. Now, nothing going away at the speed of light can be seen by you. All the radiation goes to zero. Nothing comes in from beyond 15 billion light years away. The observable universe is the only one we know about.
Yeah, but we postulate the existence of stuff beyond.
You can postulate all you like. Sit down.
But you are postulating also.
I'm simply sticking to the observations.
You're postulating about what happens to stuff beyond the observable.
No, I didn't say anything about beyond the observable universe. I just said if there's anything out there, it's not part of your universe. That's what I said.
But it gets recycled back into you.
No, not from beyond the border. Oh, Lordy, no. Don't put words in my mouth. Have enough in there already. I have to tell you something. What was that?
I just said we'll take it outside.
But I have to tell you something. My friend said a long time ago, on the last day when they put this body in the box, the mouth will still work. Anyway, we're talking about within the observable universe, the stuff has to recycle back in, because as seen by us, the redshift goes to zero energy out there. So the particles from the border can't stay at the border. It's automatic. If they're going away at that speed, way out at the border, where the energy goes very, very low, they can't stay there. They have to come back in. Now, if the stuff has to recycle from the border, and that's just required by the physics, you don't have to change anything in the physics to make it do that. It automatically does that. And if the stuff recycles from the border, we don't have to have a beginning. Don't you see? It could be going on like this all the time. The stuff's recycling from the border, and that's how the universe keeps its negative entropy up. And everything that you see here that's running on increasing the entropy is running on the negative entropy from the recycling of the universe, you see. And that's what's meaning when somebody said, and I'm quoting somebody here, that it's alive. The whole universe is alive. But I had heard it before, and I never took it seriously. But I thought, my God, you see, the defining characteristic of a living organism is it directs a stream of negative entropy upon itself. And damn it all, the universe does the same thing. See, people think this is all inert and insentient, and we're smart, we're sentient. Well, that's bullshit, you see. The only reason we're sentient is because matter is sentient. Mm-hmm. If the proton has to discriminate. Protons, electrons, neutrons, spin up, spin down, gravity, electricity, and inertia. So what the hell else is there? If they didn't discriminate that, then none of this would work. Don't you see? If the table didn't know where the Earth was, it wouldn't be sitting here on the floor. It wouldn't be sitting here on the floor. So you see, matter is sentient. simply do not see what's going on here at all. There isn't anything called matter, it's just energy, and what we don't see is that it's like that. What we see as matter is energy. We're not doing anything
They're one
but
and the same.
there's only one thing here. Energy is the underlying existence showing in space and time.
Yeah.
It is often said that the speed of light is the ultimate speed limit of the universe. You cannot get a material particle to be going faster than the speed of light. And the question is, why is that?
All right. It's because it's not a speed at all. The speed, what's called the speed of light, is the ratio of space to time. 1 light year is equal to 1 year. We didn't notice that it was like that, and we thought because you have a distance and you have a time that it was like a speed. But speeds add and subtract to each other. Suppose there's a train going 20 miles an hour and I'm walking this way 5 miles an hour. As seen by you, I'm going 15 miles an hour that way. Walking this way 25 miles an hour that way. Speeds add and subtract to each other. The speed of light doesn't add and subtract to anything. Now let me give you an example. Suppose we have a spaceship that blasts off the Earth at 99% of the speed of light. That's not forbidden. Now it can shoot a rocket out in front of it at 99% of the speed of light. That's not forbidden. That can shoot a bullet out in front of it at 99% of the speed of light, and that's not forbidden. Now let that bullet have a headlight. The headlight goes with respect to the bullet at the speed of light, with respect to the rocket at the speed of light, with respect to the spaceship at the speed of light, with respect to us at the speed of light. Don't you see? The speed of light is not the speed of anything. It's a ratio of space to time. People tell me, if you went at the speed of light, time would stop. Now, time is the only thing that can't start and can't stop and can't speed up and can't slow down. All motion is with respect to time. And time doesn't have any motion. With respect to what? Is time going to move? Then you have to have time for that to move and time for that to do that. Oh, Lord. People don't think straight. They don't think straight. When you say that something is moving, it's moving with respect to time. There's no use saying that time is moving. The universe is like a television show. We all came in the middle and nobody's staying for the end. So it's a little bit like a theatrical performance. So if you go to a theatrical performance, there's several things you want to know. Who are the actors? It's hydrogen and helium. What is the name of the play? Falling. Where is the theater? In space. And what is it? When should you go? In time. There's a real famous definition of time, you know. It comes from the men's room in the Pecan Street Cafe in Austin, Texas. And what it says is that time is nature's way of keeping everything from happening at once. Now, isn't that lovely?
That's wonderful.
Now, in the ladies' room, it should say, space is nature's way of keeping everything from happening in the same place. Now, I asked some little kids one time, what was the opposite of a squirrel? And this little kid, he's second grade, he says, a crocodile. Now you see, they're both living organisms. Don't you see? He didn't say a stone. He said a living organism. Now usually if I ask the opposite of a dog, I get cat, because they're household pets. You do see that. Usually when we say that two things are opposite, we have already seen that they're identical in some way, and then in that way they're opposites. So it looks to me as though space and time are identical in some way. They're both dimensions. But they're opposite in some way because one's plus and one's minus. We see the Andromeda Galaxy about 3 million light years away by seeing it 3 million years ago. And if you put these 3 million in here and square it, and 3 million in here and square it, what's your remainder? 0. Now, that puts a very different look on this universe, because every event which we have ever seen with our eyes, which made us think that the universe was out there, every single event that we have seen out there had zero separation from our seeing it. Now, I'm not responsible for this. Einstein's not responsible for it either. If you want to blame anybody, you've got to call up the exterior decorator. Suppose a light beam can get from this event to this event. You think something bebopped over there. But they're adjacent in space-time and nothing bebopped over.
So you're saying an event is adjacent in space and time?
No. I said if the distance between two events is equal to the time between the two events, then they're adjacent in space-time. They're not adjacent in space, and they're not adjacent in time, but in the real world they're adjacent. And that's what we don't see. If there's an explosion, and I see the explosion here, then you see there's a time between the explosion and the time I see it here. And there's a distance between the explosion and the place where I see it here. And the time and the space are equal. And the total separation between the event and my seeing of that event is always zero. Now, the interesting thing about this is this, that the notion that the universe is out there, in the goddamn pendant of us observers, is based on the fact that we see things out there. And it turns out that the evidence that we have for its being out there is all wrong. The evidence is that it's not out there. The separation between you and what you have seen in your entire life in the waking state is exactly the same as it was in the dream. When you wake up for a dream, then you understand that all those things that happened were not away from you in space, it was in you. I'm sorry that that's such a difficult thing to get through people's heads, but it's difficult because our genetic programming does not see time as anti-space. You know what I tell the people in my classes? Everything we know about this universe has been figured out by people as stupid as we are. If they can do it, we can do it.
Right.
Not only that, but if you figure it out for yourself, it doesn't matter who figured it out before. If you figure it out for yourself, it's your own.
Do you think it has some kind of boundary or something?
It has a boundary. The observable universe obviously has a boundary, 15 billion light years away.
But is there more beyond that you can't see?
Now you see, that's the interesting thing. If there is something beyond that, what the hell is it? Now, there were some other physicists who used the word energy 4,000 years earlier, and they even had E equals mc squared built into the Sanskrit language. Anyway, their word for the universe was Jagat, the changing. Now, these are physicists. If the universe is the changing, damn it all, there has to be something against which it's changing. If you're going 60 miles an hour, it's with respect to the road. Take the road away and you're gone. There has to be something with respect to which you change. So they said there has to be something that's not in time and not changing, and therefore not in space and not divided and not finite. They said there has to be something underneath what we see, and it has to be changeless, it has to be infinite, has to be undivided, and it has to show through. Why? Because the only way to get from the changeless to the changing without changing it is to make a mistake. So then they analyzed mistakes, and they said, if you mistake one thing for another, there are three things you had to do. First, you had to fail to see what it really was. Second, you had to jump to the conclusion that it was something else. Thirdly, you had to see it in the first place where you never would have made a mistake that way. If you mistake a Ford for a Chevy, it's because you saw the Ford. You didn't mistake a cow for the Chevy. Okay? So they said that one is the veiling power, one is the projecting power, one is the revealing power. So they said what's underneath has to show in what we see. And it has to be changeless, it has to be infinite, it has to be undivided, and it has to show through. To me, that's a very interesting way of looking at this. So then if you ask what is beyond the observable universe, it has to be the changeless, the infinite, the undivided. But we think there's a big empty space out there. That's entirely guesswork. So the undividedness has to show that's gravity. The infinite has to show that's electricity. And the changeless has to show that's inertia. If that model gave rise to some other kind of physics, it wouldn't be interesting. It gives rise to the physics which we see and for which we have no explanation. Nobody at Caltech knows why bicycles coast. They know how they coast. They have no idea why things fall. They know how they fall. They have no idea about any of this stuff. No idea about inertia, no idea about gravity, no about electricity. And if you ask about it, they'll send you to church. Anyway, that's the way I see it. There has to be something beyond the observable border, but we don't have to assume that it's space. But you first have to understand whether space and time has to be real or whether it might be this kind of a thing. Well, what else do you guys worry about? I want you to worry. If you don't worry, you're dead, okay? People who don't wonder about things, there's no use for them. Anyway, somebody has a hand up over here.
Oh yeah, I was wondering what you thought we would do with the ozone in the future.
The ozone?
The depletion of the ozone.
Well, we're having trouble with the ozone already, and I don't know what we're going to do, but my own feeling is that the business people are going to rule like they do now, and they don't give a damn what happens to us. The human race is not particularly concerned with what I see as the big problems. The human race is not concerned with it. We're all born thinking that this world is the whole universe, and that this world has been there forever, and it will be here forever. That's bullshit. It's going to get melted. There are no permanent habitats. Habitats are temporary. All habitats are temporary. There are no permanent habitats in this universe. They're born on the surface of a planet, and they don't think there's anything out there very far. They think the sun and the moon are a couple of 100 miles out there, and they're the same distance away, and they're not very big, and they're not very important. And they don't think about anything beyond the surface of the earth. They're genetically programmed to think that this earth is permanent. Almost everybody in his guts feels that this world is permanent and that that's all there is. You look at all the religious people, it's about this earth, it's not about the rest of the stuff. It's about this world. God made this world for our use. As I always say, the fish would have been boneless. I would like to get the physicists back to their equations, to Einstein's equations. They have mistaken all of special relativity, both the geometry and the physics. They've taught it to you the wrong way all over this planet ever since 1905. I want to get them back to the physics, the way the real world, the way the exterior decorator does it, and back to the geometry, the way the exterior decorator does it. And I'd like to get the Vedantins back to the Vedanta, back to what those old physicists saw. Because the Vedantins have gotten off too. They go into all kinds of spooks, and they don't do things the right way. So I have trouble with both the Vedantins and the physicists. Got to get the Vedantins back to Vedanta and the physicists back to physics, and then we only have one thing. We don't have two things. As soon as the Vedantins are back to Vedanta, they're back to physics. And as soon as the physicists are back to their physics, they're back to Vedanta. There's only one thing here. See how easy that is? It goes around like that. And then you can run it down here like this. Now let's see if I can step out of it. Now that's all you need to see. Well, if everything is understood, we can quit.
Okay, let me ask one last one. Do you have any advice for us for living a long, creative life?
Eat. But you have to be careful what you eat. Now you see, the American diet has almost all the B vitamins taken out. And the vitamin C that is destroyed by pasteurizing the milk is more vitamin C than is available from the entire citrus crop. Now, I'm not against drinking all raw milk because there's some other things you can get from it, but still you need to take your vitamin C because everybody on Earth makes its own vitamin C except guinea pigs, fruit bats, and you! So you need to get some B vitamins and you need to get some vitamin C.
Wanted to
This kid asked me if I was an astronomer or a comic. I said, this is a funny universe and I'm not responsible.
So it sounds like, just from how you were able to answer questions, that you've done a lot of self-teaching.
Well, yes.
All that stuff.
I've been exposed to a lot of things. People ask me sometimes, how come I know all this stuff? I say, you stay awake at night and get very old. The moon. Come see the moon. The moon. The moon.
Sure.
Whoa. That's the right noise. Come see the moon. We're looking at the moon. Come see the moon.
The Sidewalk Astronomer.
Yeah.
Come see.
Yeah, where do we look through? Right here?
You are here.
Oh
I was told you were a myth.
You what?
I was told you were a myth. But our astronomy professor told us about you.
I'm not a myth.
But then I could never find you, so I was like, he must not exist.
Seeing the view.
Wow! That is incredible!
I know, the exterior decorator does lovely work.
Why are you here?
Well, who else will?
Well, there you go.
Well, there are other people that do it now. But the Sidewalk Astronomer started in '68, you see, and this is what we do. When I first looked through a telescope, this is way back in the 40s, in the 40s, no, 50s, the late 50s. I thought, my God, everybody's got to see this. So that's what happened to me. Watch it, might happen to you.
If Lou Franken would let you take a look.
It's so gorgeous.
Thou hast lifted all my sorrow with the vision of thy face and the magic of thy beauty has bewitched my mind. Anyway, that's how it does.